All right, hello again. This is Jeff Scott coming at you with JavaScript, courtesy of Murox JavaScript 2nd edition. We are now beginning our launch into section 2 of this 3-section book, Chapter 7, which starts on page 199 and is entitled How to Work with Numbers, Strings, and Dates. Use number, strings, and date objects in your apps. Use the global is_nan to check if a variable contains a valid number. Use the random method of the math object to generate a math integer within a specific range. Describe the special numerical values infinity, minus infinity, nan, number.max value, number.min value. Describe these methods of the number object, toFixed and toString. Describe the math objects round, seal, floor, min, max, and random. Describe the JavaScript escape sequences, \t, \n, double quote, single quote, and \\. Describe the string methods, length, index of, string, 2 lowercase and 2 uppercase. Describe how to create a date object with a current date and time. Describe the date object methods, toString, toDateString, toTimeString, getFullYear, getMonth, getDay, setFullYear, setMonth, and setDate. All right, so let's start with these properties of the number object. Number.max value is the largest positive number that can be represented on your system, whereas number.min value is the smallest number. Number.positive infinity represents positive infinity, and number.negative infinity represents negative infinity. You'll notice that with each one of those first 4, after the dot, what comes there is all in caps, meaning that that is a built-in JavaScript constant. Number.nan represents a value that is not a number. You already have known that. So here's some examples where you can test for infinity, non-infinity, nan. So again, 0 divided by 0 displays not a number. 10 divided by 0 displays infinity. That actually is important because in many programming languages, if you divide a number by 0 and run the program, it tries to figure out infinity rather than just display it, and your program throws an exception, which is an error condition. So the toFixed method of the number object returns a string that's rounded to the number of digits. I already showed you that when I did a division, and I took the number and I rounded it to 2 decimal places. Typically you do that for dollars and cents, or possibly minutes and seconds, or whatever. Dollars and cents is probably the biggest one. ToString returns a string to the number of the given base. If you omit the base, it's assumed that it's base 10 or decimal. I believe if you preface a number with 0, it's going to think that it's base 8, which is octal, and if you start it with a 0x, where the x can be upper or lowercase, then I believe it thinks that you're using base 16, which is hexadecimal. So here's a toFixed example, but I don't think it's anything you haven't already looked at. All right, and here is a explicit use of the toString. So most of the time, JavaScript is smart enough to use a toString when it needs to for you. Some common methods of the math object. ABS returns the absolute value. If you don't know what that is, if I'm 59 years old and my friend Bob is 35, okay, then there's 24 years between us. It doesn't matter if you say 59 minus 35 or 35 minus 59. Either way, there's 24. So what math.abs does is it gives you the absolute value. If it's negative, it drops the sign. Round, if it's 0.5 or above, it'll round up to the next value. All right. And if it's less than 0.5, it'll round down. Seal returns the next higher integer. So if you've got 5.3, the seal will return 6. If you've got negative 5.3, it'll return negative 5. Math.floor is the lowest value, so floor on 5.3 would return 5. Floor on negative 5.3 would return negative 6. Math.power is how you raise something to a power. So if I said math.pow, as you see right there, and I put in here 3, 2, that would be 3 squared, or 9. Math.sqrtx returns the square root. Math.max, these are some interesting ones, and we'll look at those in a little bit. It returns the largest value from its parameters or the smallest number from its parameters. So the max and min can take one or more parameters. If there's no parameter, max returns negative infinity and min returns infinity. Here is an example of the absolute value, rounding, the ceil and the floor methods, the pow and the square root methods, the min and the max. All right. The next thing that's discussed on pages 204 and 205 is the author talks about the math.random function. Now, virtually any kind of programming language that you use that returns a random number really returns a random number that's greater than or equal to 0 and less than 1. Because there's literally an infinite number of numbers between there. So it's less than 1, but it could be as low as 0. So it could be like 0.999999, etc. When you want to go and, that may or may not help you, but what if you were doing a game where you wanted a number between 1 and 6, let's say, because it was going to represent die. So then we could say this, this is a number between, that and 1. So we can do something like this, and there's plenty of ways of doing this. So I could generate a random number between 1 and 6. So I've assigned a program in the past where I ask people to do this. And some of the stuff we already looked at earlier. But I'm going to say here, JavaScript, random number between 1 and 100. All right, so I have people come in and create an array with 25 numbers in it, but the numbers have to be between 1 and 100. Again, with a math.random, you're going to get a number like this. That's greater than or equal to 0 and less than 1. But if we look at this, this says take that math.random, multiply it by 10, and then add 1 to it. So if it generated 0, 0 times 10 is 0 plus 1 is 1. If it gave us a number 9.99999, etc., and we multiplied that by 10 and added 1, that would give us 10. All right? So if I change this number from a 10 to a 100, it would give me a random number between 1 and 100, like you see right here. So you can use the getRandomNumber function in this figure to generate a random number between 1 and a specified value. That's the function that's shown right here. Random numbers are used for testing. They're used for games. They're sometimes used for animation, to move something on a screen in a different way. There are many different ways to create a random number generator. All right, so if you wanted to look that up, you can find that. So what the author does next is he creates a game. Pig is actually a game. Look at the rules here. The first player to 100 wins. Players take turns rolling the die. The turn ends when a player rolls a 1 or chooses to hold. If the player rolls a 1, they lose all their points they got during the turn. If they hold, their points remain and they're added to their total. Okay? So notice it's Mary's turn. She did a roll, she got a 1. So Mary should be losing all of her points. Okay? I wouldn't call it a game of chance, well, a game of skill, as much as it's a game of luck. So we can look at it, and I can play it. I'll probably show you because I've never played it before. So I can probably show you how bad I am in it. Again, source code, book apps. Now this is chapter 7. Copy it. There's Pig. Let's play it. All right. So I'm player 1. New game. Please enter 2 player names. Okay. Jeff, and I'll be my wife also, Sandy. So, new game. Jeff's turn. Roll. 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 Ah. Sandy's turn. Roll. 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 Ah. Jeff's turn. Roll. Sandy's turn. Roll. roll. Jeff's turn. I'll never get to 100 this way. Roll, roll. I'm gonna hold. Sandy's turn. Roll, roll, roll. Jeff's turn. Roll. See, I've lost my points. Oh, it looks like I might keep my points. That's good. Roll, 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 hold. Jeff's turn. Roll, 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 hold. Sandy's turn. Roll. You see what's happening here. So the HTML for this is shown. Starting on it's on page 207 in the book, and you see it down here and here. Not really a very complex interface. The JavaScript is shown on page 209, and it's on several pages here of the PowerPoints. It consists of 7 functions, starting with our old familiar alias function. Then we've got a get random number function that was used and was brought up earlier. Then there's a change player function, which is called when the turn from one player ends. Then there's a new game function if we want to start a new game. The roll dice function, all right, which is going to generate the random number between 1 and 6. The hold turn function, all right, which is the event handler for the click event for the hold button. And the last function, which is the window.onload event, which attaches the new game, the roll dice, and the hold turn event handlers to their particular click events right here. All right. Next, we jump into what are called escape sequences. Backspace, tab, new line, carriage return, form feed, vertical tab, double quote, single quote, double quote, double quote. And I'm not going to write a whole program, but let's just look at this. Let's look at how we'd use all of these. All right, so I'm just going to write some code. And don't worry, I'm not going to compile it or anything. So I'm going to say var, and let's say that I do this. I want to say first name equals Mary. All right, but now for whatever reason, I want to do this. I want to say var last name, and Mary's last name is O'Hara. Now I could just say O'Hara, and that would work just fine. But let's say that I'm really used to using single quotes for all this stuff. So I use single quotes here. Well, that's going to fail because it sees this and it thinks I'm done. So if I want this to actually mean a single quote rather than part of a string, I preface it like that. Now it looks at that and says, oh, that's O apostrophe Hera. So that will work. All right. If I want to say something like this, var str, I'm just going to write a string, equals to use escape characters, escape sequences, use the, and I want to say that key, but that doesn't work. All right. If I want to actually say use the backspace key, I've got to do it like this. So when you use this with this, it turns off the special meaning. All right. I've never used a vertical tab, so I can't tell you what that is. If I want to say this, var full name equals first name plus a tab. So first name plus a tab plus last name. Then the way that that will appear down below is it'll say Mary tab O'Hara. Okay? The backspace, I don't ever use that either. The only other one that I use from this list here is a new line. So if I change this, I can say, and now instead of looking like this, it'll look like Mary hit the enter key, O'Hara. All right? So hopefully that's enough to explain to you what's going on there. Here's some examples shown in the book on page 211. You can also use what's called the Unicode Character Set. All right? Now, back in the day, like in the 80s and 90s, when users were working with different character sets, you might have heard the term ASCII character set. And at that time, there were really about 256 characters that you could use. So I'm going to type in here, ASCII character set. Oh, how about an ASCII table? That'll work. All right. So here are those characters. All right. Not all of them here. I think that's half of them. Oh, there's the other half. Okay. And they represented all sorts of stuff. Now, do we have to care about that? Well, the point is that back in the time when everything was basically national and we didn't have a lot of international stuff, we didn't have to worry about Chinese, Japanese, etc. Now we do. So these 256 characters weren't big enough. So they created another thing that was called the Unicode Character Set. All right, now if I do a Unicode table, it's going to be way too big to show you because, to my knowledge at least, there are actually, in the Unicode Character Set, 65,536 values. On this page, we're only showing about 1,000 of them or so. But it handles every language that's available, and there's still some room to add additional languages. So that's, and the first 256 characters of the ASCII character code, all right, the first 256 characters of the Unicode character set are the ASCII characters. All right. So if you want to see some examples of those, which allow you to put things in other languages and use other stuff, divide symbol, etc., there they are. Okay? And there's two ways you can add these, and they give you some examples. So if you want to use the sense character there, if you want another way to display an ampersand, a copyright symbol. So these escape sequences let you insert characters that aren't on the keyboard. And the Unicode Character Set, I showed you where to go. It's also shown in your book, www.unicode.org/charts. Be aware, not all fonts provide all of the Unicode characters. If you use one that's not in the font, a filler character is used instead. Maybe you saw some of that. All right. String objects. One of the more important properties of the string object is the length. So if I type in what we had before, so let's see, if I came back here and did something like this, var str, okay, it would count and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 17, 18, 19, 20, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31, 32. I think it counts this as one character, 33, 34, 35, 36. It would come back with 37. If I said var len for length equals str dot length, I think it would come back with 37. There are several other string functions, and this is just a partial list. Char@, which returns a specified position. The reason that can be important, all right, is let's assume for a second that I have something set up where I put a program in a loop and I say enter Y if you want to return, if you want to play the game again, maybe that pig game or something else. But what if the person puts in yes? That's not a Y. So I can, if I want to, I can search just the first character by using char@. There's concat to concatenate or put two strings together. Index of, which searches a string for a string inside of it, same with substrings that you see there. Two lowercase to put something in all lowercase, two uppercase to put it in all uppercase. There's char@, concat, and index of examples. There's substring, two lower and two upper examples. You work with strings a lot in virtually every programming language. The majority of things, for example, in a database, anything that's non-numeric is almost always is going to be put in as a string, or some derivation of a string. So we've got examples here, how to trim spaces. All right. And you'll notice we've got a function called left trim, which removes leading spaces. There's one called rtrim, which removes ending spaces, and there's one called trim, which you can actually combine. And I think there is a trim one, but otherwise you can combine this, and that'll remove all these beginning spaces and all these ending spaces. If I had Java space script, it will not remove any spaces that are not at the beginning or the end. You can compare strings, and here's an example. These are the same except the case is different. So if I put them both the lowercase first and then compare them, it will say the strings are the same. You can also use the ignore function to do a similar thing. All right, JavaScript allows you to work with date objects. We looked at this back a few chapters ago. Well, that's pretty, right there, that's pretty good. 11/8/2016. Is that the actual election day? Yes, it is. Okay. So grand opening day, etc. So what you're saying is the grand opening is 2/16/2015 at 8 a.m. The departure time is 4/6/2015 at 6:30 p.m. because it's using military time. When you work with an election day, not with an election day, when you work with a date object, you can parse out any part of it. So you can grab just the year, just the month, just the day, just the hour, just the minute, and you can actually go and get granular enough that you can get not just hour, minute, and seconds, but to 1/100th of a second. All right. You can create one date object by copying another date object into it. Notice it says some unexpected results. This will say invalid. All right, because it doesn't like, I believe it's because it doesn't like the dashes here. This will use 1916. All right, so you can get some weird stuff that happens. In JavaScript, dates are represented by the unique epoch time, which is the number of milliseconds since January 1st, 1970. When you create a date object, date and times are specified as local time, which is on the browser's computer. Month numbers, this is one to remember, month numbers start with 0. So January is 0 and December is 11th. So you can use them inside of arrays. That's why it's done like that. This is how the constructor for the date object works. The bottom line is if you call it with no parameters, it does date and time. But you can call it with just the date. You can call it with just the time if you want to. So there's a lot of ways you can do this. As far as some formatting methods for the date object, as shown right here, you can use the toString, which returns a string containing the date and time, where you have basically converted it to a string. ToDateString, which does just the date to a string. ToTimeString, which does just the time to a string. And there are some examples. So you might say, fine, why would I want to convert that date to a string? Well, maybe there's a string function. You've got a date, and maybe you want to use a string function on it. Well, if it's a date object, by its very nature, you can't. But if you convert it to a string, then you can use those functions. Here's some get methods of the date object. Get means give me this. So get time returns the time. The number of milliseconds, basically it is the time. Get full year gives the 4-digit year. So it would give 2016. Get month would be the month in local time. Since this is June, it would give me 5. Remember, it starts with 0. Get date gives me the day of the month in local time, and I don't know what today is. It's about the 7th or something like that. Get hours, it's around 9 something. It would give me 9. Get minutes, about 9:10, so it would give me 10. Get seconds would be the number of seconds, and milliseconds would be that. If instead of getting values, I want to set them, most of the ones that are in here have an equivalent set routine to set the 4-digit year, set the month, set the day, set the hour, set the minutes, set the seconds, or set the milliseconds. So what? The only one that's not in here for set that I can see is set time. All right, because that is literally comes back as a constant. All right. Next, starting on 220, they give you some examples of working with dates, and they show you how you can display dates in very different types of formats. How you can calculate the number of days till New Year's. Basically, in a nutshell, what it does, and yeah, it does a calculation, but it figures out what the date and time value is for New Year's, and then it subtracts the date and time value of today and converts it over, and it says, oh, for example, on June, whatever today is, like June 8th, let's say, so what, there's, approximately, whatever it happens to be, 190 days till New Year's, and that's what it'll say. If I ran it tomorrow, then it would be 189. Calculating a due date, all right. Typically, with most programming languages, there's not a lot of mathematical methods that you can use on a date object. You might be able to find the difference between a couple dates, how to add 30 days to the date or whatever. All right. So the chapter ends starting on 222 with an example that's called the countdown application. So it presents a countdown application which accepts an event name and an event date from a user and calculates the number of days until that event. All right, so let's run that one. And we will actually use something that would be applicable to you. All right, so start of fall 2016 BTC semester. And the date is 08, I believe, let's see, I think it's the 24th, which is a Wednesday. Yep, I think that's right. So, no, that was right. 08/24/2016, which says there are 77 days until that semester starts. If I wanted to put another date with another event, Mom's birthday. And let's assume Mom's birthday is the 5th of July. All right, then it's 27 days until Mom's birthday. All right, or 4 weeks from yesterday is a way to look at it. So the HTML and the CSS are shown here. Again, it's not a very difficult thing. Very little CSS, and there's the JavaScript. All right, on the next couple pages. First, it creates the dollar function again. Then it's got a calculate day function that's executed when the user clicks the countdown button. And it has an onload event handler that assigns the calculate days function to the button's onClick event. Okay. Exercise 7.1 that's in your book on page 227 has you enhance the future value application. Again, I would recommend that you do this and take a look at it. See if you can add the date and the time and do some other stuff in here. That, again, is how you're going to learn. There's a change calculator. Okay? There's a calendar app in here. There's a lot of really good stuff in here. Okay, too much to assign and to be able to expect you to get it done, but there's a lot of good stuff in here. All right, so that finishes our Chapter 7, and I'm going to come back in just a minute with Chapter 8. And Chapter 8 is on how to code the control statements. We've seen these already, but it'll talk about them in some more depth and breadth of coverage. So I'll be back with that shortly.